Cam clip, I think it's number 8, is devoted to looking at the spinal cord. So the spinal cord is a nerve column, and it runs from the base of our brain, okay, into the vertebral canal. Remember, this is the tunnel, if you will, that's created from the vertebrae being stacked on top of each other, and eventually tapers down to end somewhere between the first and second lumbar vertebrae. So it's a nerve column. It's carrying information up and carrying information down. I'm going to go to this picture. So looking at this picture, it's a cross section of the cord, okay? And these are the spinal nerves coming out each side. And this dark gray piece in the middle represents, you can't really see it on this one too well, it represents gray matter. So we know that it's nuclei primarily. So take a minute and locate the dorsal posterior horns and columns, okay? So the posterior horn right here, okay? And then the columns would be in here because the information is going up and down. Anteriorly, we have the anterior horn, okay? And as well, there'll be columns going up and down from here. Can't see, I'm pointing up and down here. And then the central canal in the middle that contains the cerebrospinal fluid. Okay, so this just gives you an indication of where it starts at the base of the brain. And you can see here's the lumbar vertebrae. So it ends somewhere around here. And then it kind of fans out like this, called cauda equina or horse's tail. Lots of pictures here. Okay, again, just dividing it all up so you can see the dark brown piece in the middle. This is all gray cell bodies, okay? And so we would have the ascending tracts in here, okay, versus our other types of tracts around here. So ascending, going up, carrying sensory information. The interior piece of this is where we are going to have analysis made up. Okay, analysis. When we talked about reflexes, remember it came in and then it went out, but it was analyzed in here. Just looking again at a different, this shows you also the dura, arachnoid, and pia. This helps you represent the spinal nerves that are exiting, and all around this, what we would have here is we would have the vertebrae. So I'm just going to go back to that picture talking about the anterior horns. So the anterior horns right here have large cell bodies, and this is where our motor fibers go to the skeletal muscle. So if the information is coming down and going out, right, this is where they're going to analyze right here and go out to its effectors. Often our interneurons, remember they're the little connecting pieces between neurons, sensory and motor, they're in here as well. The white all around, it's yellow in this picture, is divided into anterior, lateral, and posterior. And those are myelinated tracts. They're going up or down. I mean, there's a lot of complexity here, but I just want you to get the concepts. Up or down, up or down. So what are the functions then of the spinal cord? I'm just going to go back to the function. So it's obviously conduct nerve impulses. It's taking in sensory information up and motor information down. It's also an area for spinal reflexes. We looked at that already when we looked at it in the introduction part to the nervous system. So if it's not gray, it's white. If it's white, it's moving up and down. So it creates this two-way communication between the brain and the periphery. As I said, sensory is ascending, coming from receptors, okay, receptors, up. Motor is descending, going out to effectors, coming from the central nervous system. The amount of gray matter that we see when we transect the cord represents the amount of skeletal muscle that it has to innervate in that area. The lateral horns, those are pieces. Let's go back and take a look at that picture. I should have put it over here. Sorry. The lateral horns here in this area, okay, because they're lateral to the center. I'm going to switch it again. So sorry. The lateral horns carry our autonomic nervous system. So that's the information that's going out to our organs automatically. We don't control that. We'll talk more about that in the peripheral nervous system. So the spinal cord has two functions, nerve impulses and spinal reflexes. Tracks are the communication up and down, up and down. Ascending is sensory from the periphery to the brain, so receptor to CNS. Descending tracks carry motor impulses from the brain, so CNS to effector. The fibers which within the nerve tracks originate from the cell body in another part of the system and terminate in another. So when a tract is either going up or coming down, it starts somewhere and ends somewhere. And when we name some of these tracks, and we're not going to name them all, we name them, the origin and termination is how it's named. So the first part represents where it starts, and this represents where it ends. So taking a look at this, you'll see that makes sense. So this begins in the spine and ends in the thalamus. So we know that it has to be sensory because it starts in the spine and goes upward. Corticospinal starts in the motor cortex and ends in the cord, so we know that it needs to be motor or it's descending. So that's how we look. Now there's lots of tracks. Again, we're just looking at this concept. So looking, here's the motor cortex up here, okay? These tracks are descending. Remember, we always said they usually cross, and they're going out to an effector, and in this case, it is a skeletal muscle. This represents an ascending tract. It's bringing sensory information from the skin and going up, okay? And it's going to a part of the cortex in which it needs to examine to bring you information about pain. There is something called pyramidal tracts, descending motor. They're corticospinal, so they start in the cortex and in the spine. And they originate up in the primary motor cortex. We talked about that earlier. So imagine the cortex being like a quilt on top of your head, and each patch looks after something like motor or sensory or whatever. So this is in the motor section. And the fibers come together in the medulla, and what they do is they form these pyramids, and that's where the name comes. They are voluntary and somatic. So that means they're going to muscles. Voluntary and somatic. Extrapyramidal are tracks that are motor tracks that are other than the corticospinal tracks, and they go to other sites in the brain, thalamus, cerebellum, brainstem. They play an important role in our autonomic movements, so walking, swimming, things that we do all the time, smiling, frowning, things like that. Those become important when we sometimes medication that people take for mental health cause what we call extrapyramidal signs. And so that's why we want to mention them for when you get to pharmacology.